A thin belt is girded around a patient's chest. The belt is a 200 turn coil. The patient inhales. The area encircled by the coil increases by 39 square centimeters. The magnitude of the Earth's magnetic field is 50 microtesla, and this makes an angle of 28 degrees with the plane of the coil. Assume a patient takes 1.8 seconds to inhale. Find the average induced EMF in the coil during that time. Okay. So what we're going to do here is we're looking for an EMF, and we know EMFs can be given by a change in flux. All right, so this is the number of coils multiplied by that change of flux. Remember, there's always a negative sign out here. Okay, so I know that flux is an integration between B dot dA. Okay, in our case here, being our area is uniform, it's a uniform circle. We can go ahead, it's fully enclosed. We can go ahead and pull those out. B remains constant, or we'll have our flux as being BA cos theta. Okay. So when we plug that in, we need to determine what is changing. So we'll have the EMF produced is equal to negative N, and then there'll be some change in this, BA cos theta, and that changes over the amount of time that that change takes place. So we have to figure out which one of these is changing. So if we go through, B remains constant in the problem. It doesn't say a change in B, so I pull B out of the equation. Area does change. It says that when the person breathes in, the coil will increase by an area of 39 centimeters squared. So the area does change. So you could write it as area final minus area initial, or simply change in area. And then the angle, cosine theta. Theta was stated to make 28 degrees. 28 degrees does not change, especially over the shorter amount of time, 1.8 seconds. Okay, so then we have to start plugging in those values. Okay, so the EMF, we have 200 turns. Okay, so I put in my N. I also made this absolute value since it's asking for average EMF. When the person breathes in, there'll be an EMF. When they breathe out, there'll be a negative EMF, and so on and so forth. So I'm looking for the average EMF. So we'll have 200 is the number of turns. Magnetic field B is 50 microtesla, given in the problem. The area is a bit more tricky. You have 39 square centimeters. Centimeters does not work in our standard SI units. So if we have 39 square centimeters, we need to multiply that out to get it into meters. And I know that 1 meter is 100 centimeters. To get that squared, I need to square the whole thing. So 39 square centimeters is equal to 0.0039 square meters. So 0.0039 square meters. And then the cosine is 28, that doesn't change. And this whole thing has been taken over this small amount of time of 1.8 seconds. If you plug that into your calculator, you should get an answer here in EMF of maybe 0.0000191, or you might get 1.91 times 10 to the negative fifth. You can always convert that over to get our answer of